the Virtually Speaking podcast. My name is Pete Fletcher, and joining me as always is my good friend, Mr. John Nicholson. John, how you doing, man?
Good. I'm messing with my networking settings. I'm trying to get more speed out of it. I'm off Wi-Fi and I'm running Ethernet, but I've got this really confusing data path. Like the cable runs under the rug, and there's like a switch here, but it's a PoE switch, but it's powered by PoE, but it's not getting enough power. So something I need better networking performance. I need to figure out what to do.
You don't just, you're at home. You don't just have like Wi-Fi at home like every other simple user. You've got a full-on system.
I mean, there is a Wi-Fi 7 access point under my desk, but sometimes you just like cables plugged into things.
Yeah, for various reasons, right? For security, for performance. Okay, let's not beat this segue to death. We're having a good conversation today around an announcement at VMware Explore last year, talking about inside vSphere 8, something called Distributed Services Engine. We're going to get into it with our good friend, Mr. Dave Morera. Dave, welcome back to Virtually Speaking.
Hey, Pete, John, nice to see you again, guys.
Yeah, Dave, you've been busy, man. You've been hitting the UserCon circuit, talking about VCF, talking about vSphere, all good things. You've been staying pretty busy. I've seen you on some cool videos I want to talk about, but how have you been, man?
Good. It's been a lot of fun. I love learning new things, and I also like to share that knowledge to other people, and so hopefully this would resonate with some of the audience.
Yeah, absolutely. Yeah, so I'm referring specifically to a blog I read of yours, like right after the announcement. So VMware Explore starts talking. A few years back we started talking about Project Monterey. And I was like, what is this Project Monterey thing? I remember back in the day, it came out a few years ago, and I started reading some of the content that you wrote, talking about how people are using DPUs, the rise of DPUs, and how that then ultimately evolved to VMware incorporating some of that into what was Project Monterey, which is now the Distributed Services Engine. Yeah, and so I want to start, let's before we get into the Distributed Services Engine, let's talk a little bit about DPUs in general, sort of what they are, how people are using them, and then maybe we can get into, what it looks like inside of vSphere and VCF. So maybe you can start with that, real high level, sort of what are DPUs, what do they look like, and and how are people using them?
Sure. It could definitely get confusing with GPUs, TPUs, IPUs. There's a lot of names floating, a lot of processing units out there, right? And that's something that we've been seeing. The hardware revolution is starting where, we can only go so far with the software, but now the hardware is getting better and better to support a lot of these workloads, offloading, and especially now that everybody's talking about AI. But a DPU is a data processing unit. And it actually, it's also known as SmartNIC. So it looks like a network interface card, but in addition, it has flash. So you can install, flash storage in it. You can install some operating systems or any kind of coding in there. But it also has an accelerator, and it has an ARM CPU, right? So that communication there's a high-speed communication between the accelerator and the CPU. And this is what we know now as the SmartNIC or a data processing unit, right? So it's a piece of hardware, PCIe device that gets installed on your server.
I heard you also talk about SmartNIC. SmartNICs, I thought had been around a little longer. So it's basically, what's the differentiator with the DPU? Is it this offload engine or?
It is not just the offload, right? SmartNICs, what we used to call it's smart NIC with an accelerator. We can offload some things to it, but not everything. So the ARM processor that we're adding to this NIC, to this interface, is that it's going to allow us to do a lot of the high-end processing instead of going up to a server or an x86 CPU, right? So this is the additional piece that's been added to this interface.
So I guess, we've got this ARM, we've had ESXi on ARM here. What am I, obviously I'm not just going to vMotion my regular VMs to this ESXi instance, running on ARM. What workloads are going to run on there, and how am I going to deploy them?
So the way we're using this is taking advantage of that processing unit on the SmartNIC. So we're taking services from x86 that don't really have to do much with data or workloads that customers are using, and we're trying to offload those to the processing unit, the CPU on the SmartNIC. So by doing that, we are not only installing ESXi on the SmartNIC, but we're also offloading, in this case, NSX services. So instead of pinning CPU on the x86 box, we can utilize the SmartNIC to run those services, and we're freeing up some of that all those resources back to the x86. So the VMs would take advantage of all this, right? Because not only are we running that separately, but the VMs now have more resources as far as CPU, and we can either increase their sizes, increase the resources for those VMs. We can add more VMs, so that's going to give us a VM consolidation, a better ratio there. And not only that, but we also have a physical separation. So we have that separation between the x86 CPU and the SmartNIC CPU, and it is going to decrease your attack vector because now you have services running in different places, right? And as we know, software, any kind of software, the more features we add or it's available, is going to consume more resources. So this is an easy way to offload and utilize the processing power that customers purchase for the workloads, just for that. So it also helps them with minimizing the amount of silos that they need. For example, buying a cluster specifically to run AI, or a cluster specifically for their high-end applications. Now by doing this, they can actually take advantage of that VM consolidation and run consolidate those silos together too.
So I guess the low-hanging fruit here are going to be I/O intensive or network intensive applications that have that are fundamentally CPU bound in some way today, or core bound, or just have, I guess, large core associated costs. So big databases doing big things for AI. If I'm running my vector database or something there, being able to push that data more efficiently without having to use as many cores.
Yep. Yeah. The high network applications definitely take advantage of the DPU, right? Because if you think about it, as the data is coming in, they're going to hit that SmartNIC first, right? It's going to utilize the accelerator, just like we did with performance network interfaces. But in this case, it doesn't have to go a layer up to the x86. It's actually going to go sideways to the ARM CPU and say, okay, I need to run this. I need to figure out where I'm going. You do the process, and instead of me wasting the x86 processing power there. So that it's going to speed up a lot of that network communication, right? And we don't have to. It's going to save us a hop also, and not utilize the x86 CPU. So that's definitely a big advantage to using that. And you mentioned also the pricing, right? So a lot of people ask, well, why would I buy a DPU? They may be, they're definitely more expensive than a network interface card, but the difference is not that much. I mean, I've been looking around just eBay and things like that, or whatever vendor out there. The difference is about $1,000. If you were to upgrade your servers to install a bigger, more CPUs, if you even have room to put more CPUs in your server, that may cost you more, right? Because sometimes they're paired with specifically DIMMs within the server. And now not only do you have to buy CPUs, you have to buy memory to go with that, or two cores, etc. So that's going to cost you substantially more than just adding or replacing a NIC with a SmartNIC or DPU.
Well, and I think about some of these really intense high I/O applications and things like this. Network function virtualization is an example. When you think about some of those magic networking boxes you had in the data center, some of those actually already had FPGAs and offload cards for years. Was how they were able to accomplish what they did. And it looks like you're kind of being able to get a taste of that magic in terms of being able to push more packets more efficiently, more quickly. And thinking from a cost model, there'll be some cases where, like you say, you just buy fewer servers, do less, do the same with less. But also some of the cases where some of those real high network stuff, like the local cell tower, they have to have local NFV functions that are doing huge amounts of throughput and things like that, or local pops and things like that. There may be just not enough room in that little tiny hut next to it or something, or they may be power or thermal bound. That's got anything that you can do to lower that amount of compute could have some really interesting implications depending on that. But like you're saying, for $1,000, I'm hearing, just compared against some of the higher end, when you're comparing 100 gig to 100 gig, I'm hearing even less than 1,000 in some cases. It sounds like this is something that even if you're not wanting to use today, it's probably a good hedging tool going forward if you're already spending 30 grand on a host or 40 grand on a host, in for a penny, in for a pound.
Yeah, that's an excellent point. If you're planning your next server refresh, right, there's no reason why you can't use DPUs for just regular networking, even if you're not using it for DSE, right? So that prepares you for to take advantage of this feature later on. But yeah, it's just a little more expensive as far as the networking piece.
So let's just say I've got a boring file server, or something, or I've got a database server that just shoves data around. It's not optimized. It doesn't know anything about P4 programming on offload engines. What is its mechanism to leverage this offload? How is that VM made aware? How does it go talk to that?
Okay, so we don't, and one of the questions we always get is, okay, how do we get your VMs into that ESXi within the DPUs? Well, that's not what we're doing, right? So we're not moving VMs anywhere. We're installing a version of ESXi on the DPUs. And what this is allowing us to do is to offload the services, right? Now, because we don't have to do extra hops and the networking piece is a lot faster within the DPU, even those, some of those servers would take advantage of that as well. And, it's just going to allow you to even run not only those network intensive applications, but it's also we're allowing you to run other networks types. So you can run storage on the DPUs. You can run, you probably want to run management in a separate NIC, but it doesn't stop you from running different types of networking in there.
So is it just the existing network interfaces, the para-virtualized interfaces that are exposed to the VM? They'll go grab and consume that offload capability for me?
Yeah, well, in this case, what we're offloading is NSX services. So we do require NSX, right? So this is not something that we support with VDS, at least not yet. But we're offloading NSX services, so we do need to install NSX. So that's one of the requirements. And once we've done that, it's pretty straightforward because we're still using vCenter, we're still using NSX, we're still using ESXi. So it's not like you're going to have to go out and learn a new application or a new UI of this special feature.
I don't need SDKs for my guest OSs or anything exotic. Yeah. It's just I plug in the paravirtual NIC, update VM tools, and I'm good to go.
Oh yeah, on that. So Dave, you actually you've done a great job of explaining a lot of the deployment and management. There's I think it's on the vSphere YouTube channel. There's a playlist on there for this, and you do a bunch of light boards and you walk through. There's also some click-through demo where you go through the entire installation. But one of the questions that first came up when I saw that was like, okay, so we're installing ESXi on this DPU. That means we have to manage it. Two versions of ESXi, number one, but what is the purpose of having two separate ESXi installs? Why wouldn't we just leverage the main ESXi install that we have on the server? Why does it have to have two separate instances of ESXi on the server?
Okay, so that's a lot of information I'm going to provide back to you. So first, I touch on the installation process, right? So the installation process it's the same that you go through right now. So when you boot up a server, the server is going to understand, okay, I recognize and I see this DPU. It's now part of me. And when you install the ESXi installer, it's going to say, hey, I found this thing called a DPU. It could be an NVIDIA DPU or Pensando, which is AMD now. So either one we support. But it's going to recognize it and it's going to ask you, okay, I know you want to install ESXi on the server, but do you also want to install it on the DPU, right? So from the same location, all you have to do is check a box, and that is going to go out and install the same exact version of ESXi on the data processing unit, right? So it's pretty easy. And the other thing is that once you install it there and you boot up and you add the host to vCenter, you're not going to see a separate host, right? And that's also one of the questions that we used to get a lot. Hey, I have 50 hosts and I don't want to see 50 more. And understandable, and that's also one of the benefits of DSC, right? Just the simplification of the operations, because now we're kind of hiding this under each one of those hosts. So a host, we have a DPU, but we're only showing you the host. So in a way, those two are acting together, right? The host and the DPU are one. Just you think about left brain, right? They're working together to solve a common problem, which is all this networking. Transactions going in and out. And so that's one of the reasons why we need to install it on the DPU itself, right? They need to be able to talk to each other, a common language, and that is a common language between the two, ESXi. So both of them will have their own logs. Actually, you can get the logs of the DPU through the ESXi logs, so they're kind of one and separate also. But again, they work as one. And on the just like the installation process, if you want to do an upgrade, it also going to, for example, if you want to do it through VLCM. So you select your host and you say, I want to upgrade to the next version, 8.1, 8.2. It's going to pass that information down to the DPU because now it's one entity in a way, right?
Yeah, that was definitely going to be my next question on that, was the fact that if this is managed from the main ESXi, which is of course managed, most folks will manage that through VLCM. So if I configure a cluster using VLCM and I can set my configuration to also update the DPU inside of that cluster at that cluster level. It doesn't have to be something separate.
Correct. Yeah, you don't even have to set anything up, right? As soon as we have the VLCM cluster set up, enable, then once you say, okay, host number one, go ahead and update, is going to update the DPU as well. And that's what we want, right? We want to have the exact same versions of ESXi so they can talk the same language and not new words, not the one understands some words and the other one doesn't understand them. So we want them, just like any cluster, to be at the same level. So super easy to manage, right? It's almost invisible to the customer. And the same way for NSX. So we're installing the agent. You see the host, and we're leveraging VLCM. So from NSX, if you want to install the NSX agent, you select the host and say, go ahead and deploy it. Guess what? We're deploying the NSX agent to both the host and x86 host and the DPU at the same time.
Okay, yeah, that makes sense. So I know we talked a little bit about some of the workloads. Like, what are the traditional use cases that you see folks taking advantage of DPUs inside of distributed services engine?
Well, right now, because we're only doing NSX offloading, and this is our first phase, right? There's many phases that we talked about on Project Monterey. So like John was saying, those network intensive applications really take advantage of it. And mainly because of the CPU requirements of running that. We did a lot of testing during the initial phases, beta, and we were able to get close to line rate. We can never push enough data to go past line rate or break it, right? So we found really good performance that way for those applications that really are asking for that network intensity, right? And now, so if you think about it, some of the other things that we talked about on different phases is bare metal. So if we have a server that is running Windows, is running Linux, and maybe it doesn't make any sense to virtualize it because, hey, it needs a ton of memory and a ton of CPU. For some customers, they still have those applications out there, right? They have one server, one application, that's it. But if we had a DPU with the ESXi, now we can leverage that and present to that bare metal server the same firewall rules, IDS, IPS, right? So we're still managing from an NSX perspective, and they're able to take advantage of that without having that separate silos in a way.
See, you talk about doing this on bare metal, and you talk about Windows and Linux, but I'm immediately drawn to the most logical use case for us putting this in bare metal, because the Z series mainframe. I want to see a DPU in a mainframe where we're pushing NSX services into the mainframe world, dragging them into the modern SDN world. Somebody call IBM. It'll be
kicking
fun.
and streaming, right? Yeah.
But like that sounds wild and insane, but that's the type, the direction that hypothetically this platform can go in. Of anything you can shove a NIC into of some kind, you can get there eventually.
Yeah, and that's a good point. I mean, there could be endless use cases here, and we only touched the surface so far. We've been working on a couple of years, but I know there's big plans to go after other applications, other workloads, and especially now that everybody's talking about AI, right? Any additional processing power that we can get, we're going to use it for those applications that are requiring that network transaction rate and just fast. I'm sure that's good. They're going to be utilized in different areas.
Okay. Yeah, I'm now wondering. I mean, most of the DPUs I've looked at have been 25 and 100, but I'm curious at what point we'll see like a low end IoT embedded DPU or something like a 2.5. There's a lot of ways this can go, and I know a lot of people right now are looking at this and saying, well, I'm still running 10 gig and I'm happy and I'm fine or whatever, but this stuff could have a lot of implications, not just on the the high end, the space emperors of the data center, but also for all kinds of other use cases. So fun.
Yep.
Well,
Absolutely.
it seems like everybody, especially in the world of VMware, is talking about new use cases like AI, and everyone's looking for ways to take advantage of AI in their environments. And certainly VMware Private AI has been a big talk at VMware by Broadcom. But is this something that plays into that? Like, do we see something with DPUs working, like taking advantage of that technology, or is that too far out?
I may or may not be able to answer that, but yeah, I mean,
I don't want
like
to
you're
get you in
saying, it.
trouble, Dave. I mean, I'm
No, no,
just.
no. I'm not going to spill anything out, but yeah, I think there's a lot of potential there, right? Like I was saying, there's processing units, and we need processing power for those AI applications. Um, I can definitely see a good use case there, or even share with the DPU. I know GPU. I'm sorry. I know NVIDIA has a card that has both the DPUs and GPUs in that same card.
Oh wow.
Um, yeah, which is pretty cool, and that means that they're thinking about something bigger right there. And a lot of the technology is not really utilizing this power that we're coming up with, not us as VMware, but the industry as a whole with this processing units. Just was it a week ago or so? Google announced a new processor, right? So did Meta, Meta. Uh, Meta announced their own. Intel announced their Gaudi 3, the tensor processor, AI accelerator. So everything's revolving around AI and these workloads that require a lot of power. And then we can leverage DPUs for some, GPUs for others, CPU for others. So this is all coming back to the hardware level and how do we best utilize it. And I think DSC is one of the few, maybe the only software I know that is really utilizing the DPUs this way.
Well, it's interesting you mentioned all those coprocessors, and I think there's a term XPU that I've seen Intel coin to talk about these kind of non-x86 generic offload devices. But initially, I saw there was actually one was this giant, like massive wafer that some of the analysts were showing that Broadcom had put out. And I remember reading that the thing it was something ridiculous, like 24 200 gig Ethernet PHYs. And I was like, why does a chip need that much, Ethernet? But looking at at the type of like mesh networking and crazy multi-model, these large language models, how much connectivity you need. We already had RDMA to bypass CPUs, but it kind of makes sense. The next logical step is have these really beefy AI stuff, not necessarily where the DPUs are yet today, but that same type of construct to where you're able to offload all of that. And yeah, I guess there is a CPU in the server, but at this point, you're not even having to hit the PCI bus. Like we're not even worried about PCI lanes. Yeah. The chip itself is, borderline sentient, I guess, at this point, talking out to things. And so seeing, where that's going. I know I just talked about, hey, don't worry, this type of tech will go to the small guys. On the large stuff, this stuff's getting wild. So
yeah, it is. That's an excellent point. And like I was saying, all this is going back to hardware, right? It's getting super crazy because AI is pushing that. But there's a lot of use cases that a lot of technology or software that can take advantage of that power or resources out there. So yeah, pretty nerdy stuff, but pretty cool stuff too.
I remember, I feel like 8 years ago, servers were really boring. Like you could take open a server, like, oh, where's the CPU? There's a CPU. Oh, there's 2 of them. That's fun. Oh, there's 3 PCI risers. It'll be a NIC, maybe a fiber channel HBA if we're feeling fancy. Maybe GPUs for some of the VDI weirdos. Oh, there's a bunch of RAM slots. There's some drive slots. There wasn't that much going on. And there's a RAID controller, something like that, HBAs. You could look at servers from 20 different vendors, and it was literally just figuring out where they placed those components, it felt like. And now with the direction, this really feels like we're the beginning of a new era where the x86 CPU, or maybe even ARM, is going to be one of the details of that server, but not necessarily the defining, compute piece or where the majority of the compute even happens. And that's fascinating and interesting.
Yeah, for sure.
Yeah, and that's something that we even talked about earlier today, right? That when you're looking to refresh your hardware, consider adding DPUs instead of just performance NICs, but also, hey, what CPUs you add in, what other hardware pieces you can add to your servers to get ready for the future, be future proof, and be able to utilize some of the features and options from other software out there.
Yeah, future
Nice.
proofing before was like, oh, we'll add some DEMs later. Like, it was
Yeah.
like I feel like
Yeah.
that's the majority of what anybody ever did. Like, no one really replaced CPUs or anything, but this is getting fun.
Absolutely. So yeah, link below for those that are on the video, and for those listening, link in the show notes for sure. But Dave, you wrote that blog on the rise of DPUs, which really sort of explains the whole process, gives a really good understanding of the architecture, the hardware, and some of the use cases. That was great. And then, of course, as I mentioned earlier, vSphere 8 announced distributed services engine. So there's a great blog that talks about the new features inside of vSphere 8 as it pertains to the distributed services engine. So take a look at that as well. Dave, where else, aside from the YouTube playlist, which is fantastic, that you go through all the installation and the lightboarding, explaining all of this, where else can people go to learn more about what's going on with Project Monterey, also distributed services engine?
So for now, those are the good places, right? core.vmware.com, YouTube, like you were saying, there's some information that I put out. There's new information coming in a few months, hint, hint. And yeah, I'm happy to, I'm really excited to what is coming this year, and where we're going to take the DPUs within VMware.
Yeah, I like it. I like it. Sweet. John, anything else before we let this young man go?
No, I'm gonna start looking on building some new lab hosts and seeing what weird exotic stuff. I for some reason, like I now know I need a DPU and for some reason a time sync cable for my server. So it's gonna be fun.
I like it. I like it. Well said. Yeah, Dave, as always, pleasure having you on the podcast. We look forward to seeing you at a UserCon near you, as well as upcoming VMware Explore. I know there's going to be a lot of announcements there, and I'm sure that you're going to be right in the thick of it. So thanks for joining us, and we'll see you soon.
Thanks, Pete. See you guys later.